Hey guys! Welcome back to the laboratory. In this video, we are looking at electrolysis. By the end of this video, you should be able to define the term electrolysis, describe what happens to ionic compounds during electrolysis, and write half equations to represent the reactions at each electrode. So, let's go. When an ionic compound such as sodium chloride is formed, sodium atoms lose electrons to form positive ions, and chlorine ions gain electrons to form negative ions. The natural attraction between the oppositely charged ions forms a strong ionic bond, and thus, an ionic compound. Electrolysis is the chemical process whereby electricity is used to break these ionic compounds back down into their respective elements or molecules, with the word itself literally meaning to use electricity to split. The equipment for this process would look something like this. Here, we have a beaker containing the electrolyte. The electrolyte is the ionic compound that is being broken down. Now remember, this entire process is dependent on the use of electricity, and electricity cannot flow through an ionic compound when it is in solid form. Because of this, the electrolytes must be molten or dissolved in water for electrolysis to be successful. Here, we have the electrodes. These are solid conductors commonly made from metal or graphite. An inert material must be used for the electrodes so that they do not interfere with the reaction. The electrodes are then connected to a power source, such as a battery. The directional flow of the electrons from the power source causes the electrodes to retain a charge. This electrode will attain a positive charge. We call this electrode the anode. And this electrode will attain a negative charge. We call this electrode the cathode. The freely moving ions in the electrolyte are then attracted to the electrode of the opposite charge. So, the positive ion, or the cation, will be attracted to the cathode. Now remember, electrolysis returns the ions of an ionic compound back to their neutral atoms. Cations are formed when atoms lose their electrons. So in order for a cation to return to a neutral atom, it must gain those electrons back. At the cathode, cations will gain electrons. This gain of electrons is called reduction. The concept is the same at the anode. The negatively charged ions, or anions, are attracted to the anode. Anions are formed when atoms gain electrons. So in order for an anion to return to a neutral atom, it must lose the electrons it has gained. At the anode, anions will lose electrons. This loss of electrons is called oxidation. As the process of electrolysis involves both reduction and oxidation reactions, electrolysis is also a type of redox reaction. Here's an acronym you can use to help remember the difference between oxidation and reduction during electrolysis. Oil rig, where oxidation is the loss of electrons and reduction is the gain of electrons. Now that we understand the basics of electrolysis, let's look at this process with an example. We'll start firstly by looking at the electrolysis of molten sodium chloride. In its molten state, sodium chloride splits into positively charged sodium ions and negatively charged chlorine ions. The sodium ions are attracted to the cathode. At the cathode, the sodium ions are reduced, gaining one electron to return back to neutral sodium atoms. Sodium metal is discharged and will begin to form at the cathode. In contrast, our chlorine ions are attracted to the anode. At the anode, the chlorine ions are oxidized, losing one electron to return back to neutral chlorine atoms. Now, chlorine is a diatomic molecule, meaning in its neutral state, it will always exist in a molecule consisting of two of its atoms. Therefore, the chlorine atoms formed at the anode will join together to form Cl2 molecules. Chlorine is then discharged as a yellowish-green gas. We can use half equations to represent the reactions that take place at each electrode. Half equations are used to demonstrate the movement of electrons. Let's start with the reduction of sodium at the cathode. To begin with, we had a sodium ion with a +1 charge. The sodium ion then gained one electron, which is written as E-, and became a neutral sodium atom. This half equation for our reaction at the cathode is now complete. At the anode, we had a chlorine ion with a -1 charge. Each chlorine ion lost an electron to form neutral chlorine atoms. The chlorine atoms then joined together to form chlorine molecules. Now our half equation is almost complete, but we must now balance it so that there are an equal number of particles on either side of the equation. So, as we have 2 chlorine atoms at the end of the reaction, we must have had 2 chlorine ions to begin with. And if we have 2 chlorine ions to begin with, then we would have lost 2 electrons in total, 1 from each chlorine ion. And voila! Here is our balanced half equation for the oxidation of chlorine at the anode. This time, let's look at the electrolysis of sodium chloride solution. In contrast to molten sodium chloride solution will not just consist of sodium and chlorine ions, but hydrogen and hydroxide ions from the water too. The positively charged hydrogen and sodium ions are both attracted to the negatively charged cathode. However, only one of these substances will be discharged. Whether the metal or hydrogen is discharged depends on the position of the metal in relation to hydrogen in the reactivity series. If the metal is more reactive than hydrogen, then hydrogen will be produced. However, if the metal is less reactive than hydrogen, then the metal will be produced. In this example, sodium is more reactive than hydrogen. Therefore, hydrogen gas will be discharged at the cathode and the sodium ions will remain in solution. The hydrogen ions are reduced, gaining 1 electron to form neutral hydrogen atoms. As hydrogen is also a diatomic molecule, the half equation for this reaction would look like this, where 2 hydrogen ions gain an electron each to form 1 hydrogen molecule. At the positively charged anode, the chlorine and hydroxide ions are both attracted. However, much like we saw at the cathode, only one of these substances will be discharged. In these circumstances, simple ions are discharged more readily than polyatomic ions. Therefore, chlorine gas will be discharged at the anode and the hydroxide ions will remain in solution. The chlorine ions are oxidized, losing 1 electron to form neutral chlorine atoms. And, just like we saw in our previous example, the half equation for this reaction would look like this. The sodium and hydroxide ions that remain in solution will combine to form sodium hydroxide. Here's an example of a quick task you can attempt to test your understanding of the content covered in this video. Pause the video and take your time to work through each question. Press play once you're ready to check your answers. Let's talk through the answers to question number 3. At the start of this reaction, we have 2 oxygen ions, where each individual ion has a 2- charge. This means that each oxygen ion will need to lose 2 electrons to return to its neutral state. Therefore, a total of 4 electrons are lost during this reaction. As electrons are lost during this reaction, this is an example of oxidation, and this reaction would have taken place at the anode. Here are the answers for the rest of the questions in this task. So, how did you do? Let me know in the comment section below. Before we finish up, here's an example of a past paper question on electrolysis. Once again, pause the video and take your time to write an answer. Press play once you're ready to check your work. The diagram below shows the apparatus that can be used to electrolyze sodium chloride solution. Describe how this experiment can be carried out to electrolyze molten zinc chloride, explaining how the products of this electrolysis are formed. This question is asking for us to describe the electrolysis of molten zinc chloride, not zinc chloride solution. Molten zinc chloride will consist of zinc and chlorine ions only, as opposed to zinc chloride solution, which will contain hydrogen and hydroxide ions too. It's important that you pay attention to the state of the ionic compound given to you in these types of questions, as the electrolysis of each would yield very different results. The question itself consists of 2 parts. The first part must describe how electrolysis is carried out, and the second part must explain how the products are then formed. It's important that your answer covers both of these parts to achieve the full marks here. Let's start with the first part, describing the process. The process itself requires for the use of inert electrodes that are connected to a power supply. As the zinc chloride is an ionic compound, it will consist of both zinc and chlorine ions, both of which are free to move when zinc chloride is in molten form. Now we can move on to answering the second part of this question, which is to explain how the products are formed. During this process, the positive zinc ions will be attracted to the cathode, where they are reduced, gaining 2 electrons and discharging as solid zinc metal. The negative chlorine ions are then attracted to the anode, where they are oxidized, losing one electron and discharging as chlorine gas. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!